Hello everybody, in this video we're going to look at lossless compression from code.org curriculum. Alright, let's get going. This video doesn't have practice questions, but if you're looking for them, look in the upper right, the link will be there. Alright, quick review time. So we learned about encoding to binary, which is really just converting human information to computer information. So in particular, numbers, text, images, we showed how to encode those into binary. We also learned that with more bits, I can store more information, and there's a formula that we have for that. 2 to the power of bits is equal to the combinations. So we looked at it with numbers. If I want to store from 0 to 99, I need 7 bits per number. If I want to store from 0 to 999, I need 10 bits per number. And if I want to store from 0 to 9999, I need 14 bits per number. We have a similar story with text. If I want to store lowercase letters, I need 5 bits per character. If I want to store lowercase, uppercase, some symbols, numbers, I need 7 bits per character. If I want to go all the way and store emojis, I need 32 bits per character. And again, we see the same story with images. I can store a black and white image. And if I add more bits, if I use more bits, I can store this black and white image instead in color. And if I use even more bits, I can store this image at higher resolution and with more and more shades of color. But there's a problem with all this, and that's this. Bits cost money. You can see it here with the latest Samsung phone. The more storage I have, the more it costs. Or here with the iPhone, the more storage I have, the more it costs. So what am I supposed to do? Well, the answer is we're going to use something called compression, which you actually use every single day and you don't even realize it. So here's an example. Let's say you're texting your grandma. You're asking grandma, how was your weekend? Grandma replies to you and you say to grandma, what the heck, grandma? TMI, too much information. So in this text example, TMI stands for too much information. And TMI is 3 characters. Too much information is 20 characters. So every time I use TMI, I'm saving 17 characters. And in UTF-8, where one character is about 1 byte, I'm saving 17 bytes, or 136 bits, every time I type TMI. So for most of my historical students, that makes sense. But this system falls apart under certain conditions. The first is, you might disagree on what something means. So what does WTH mean? The second is, grandma might not know what TMI means at all. So then what do? So the answer is we're going to establish something called a dictionary, which allows us to reversibly go back and forth between compressed and uncompressed. And the key word here is reversibly. It's a concept and term that shows up in AP CSP questions. So I've highlighted it here twice because it's super important. Reversibly. So now I'd like to take a second to summarize what we've gone over so far. So we introduced the concept of compression. And when something is compressed, it's smaller, which helps us solve the problem that information gets too big to store. Compressed information is going to be smaller, so we're going to save space, we're going to save money, and we're going to transmit over the internet faster. Basically, any problem that gets worse when you have bigger file sizes gets better the more compression you have. The second concept we're introducing is the concept of reversibility. And when we have compression that's reversible, we call that lossless. Lossless. So this means we can compress something and uncompress it, and when we do, there is no loss of information. These are the key terms you'll need to know when you take the AP CSP exam and you're answering those questions. Code.org has a great video that goes over lossless compression as well as lossy compression. I definitely recommend that you see it before trying out the code.org activity. Here is the code.org activity. I assume you can read the instructions by yourself, but remember what we're looking to do here is compression. We're looking to save characters, save space. So if you remember my example from grandma, if I need to tell grandma what LOL means, there's a cost. I have to tell her what LOL means. It means laughing out loud. But then every time I use LOL, there's a win because I'm saving characters every time I type LOL. So that's the concept behind what we're doing here. So when I apply that concept to this song, I see I was lost. It shows up here. And it also shows up here, here, and here. So I'm going to substitute a star in for I was lost. And let's see what happens. So first I have to define what the star means. So I basically say star is equal to I was lost. So the star is 1 character. I was lost is 10 characters. So it's a total of 11 characters. And because each character is 1 byte in this character set, that's a total of 11 bytes. So my total dictionary size is 11 bytes. So that's a cost. But then I get some savings. Every time I substitute that star in for I was lost, I'm saving 9 bytes because I was lost has 10 characters. And the star has 1. So I'm saving 9 characters every time. And because 1 character is 1 byte, I'm saving 9 bytes. I was lost showed up 4 times in the text. So overall, I'm saving 36 bytes by using the star instead of the full I was lost. And if you look here in the widget, it says the original text was 240, compressed text was 204, subtract the 2, I get 36 bytes. So everything lines up as we would expect. So that's the concept. I can keep on going with it. I see didn't know shows up 7 times. Didn't know is 11 characters. The umbrella is 1 character. So I am saving 10 characters or 10 bytes every time I use this. Remember that 1 character is 1 byte in this character set. It shows up 7 times, so I'm saving 70 bytes from this abbreviation. And if you check the math, before my compressed text size was 204 bytes, now it's 134 bytes. So the math agrees, I saved 70 bytes from this abbreviation. So I can keep on going here. I'm shows up a bunch of times. I'm truthfully is a small win. I'm substituting in 1 character for 3, but I can make it a little bit better by including the underscores on each side. So I gain about 1% of compression there. I can do the same thing for I, gives me a couple percent as well. I can even nest symbols. So here I'm doing it kind of quick, but I can have the dictionary refer back to another thing in the dictionary and gain about 0.5% here. Truthfully, this is not that important. If you didn't catch this, don't worry about it at all. Finally, there's a few remaining ones. I've already got all the big ticket items, but this gets me up to 41.25%, and that's about as good as it's going to get. This final number doesn't seem all that important, but it actually is super important for the AP CSP exam because it shows a concept that's really important. Lossless compression will not give you a ton of compression. Basically, there's no way to compress something reversibly and be able to compress a ton at the same time. You're going to need something called loss-C compression, which we're going to learn about later. But again, this is super important. It shows up all the time in AP CSP questions. So next I'm going to show another song that's going to illustrate some other concepts. So I'm going to pick the last song here, get rid of this dictionary, and I have a new dictionary. And for my dictionary, I'm going to say 8 A's is equal to the star. And when I do that, I get 80% compression. And you're going to say, Dr. Wu, didn't you just tell me that you can't get tons of compression with lossless compression? And I'm going to say, yes, I did. And that's true most of the time. But remember that lossless compression depends on finding repeating patterns. And in this case, I have an extreme repeating pattern of 8 A's over and over and over and over again. This is a concept that sometimes comes up on AP CSP exam questions. The second concept I hope you see is that not everything will compress the same amount. So different songs, different videos, different pictures, different texts, they will compress different amounts losslessly depending on how many repeating patterns we can find. Code.org now has a couple of questions for you to answer, and the first one is, what is the most important quality of lossless compression? When you think of lossless compression, the first thing that should come to mind when you're answering these AP CSP type of questions is that it is reversible. So that eliminates C and D, because C and D say cannot be reconstructed back to the original. So then it comes down to A or B and whether you believe compression usually or always makes it smaller. Code.org answers usually. I'm not sure I agree with that, but if Code.org says it so, then it must be true. So your answer here is A. Next question has to do with file sizes. The file is 1,000 bytes. When it gets attached to email, it is 750 bytes. What happens? Now, truthfully, in the real world, this could be file corruption. It could also be the same file being different sizes on different file systems. But given that we just worked on lossless compression, that's for sure what Code.org wants you to talk about here. So what's going on is the file is 1,000 bytes when it's uncompressed. You compress it losslessly to 750 bytes. And then when the person receives the email, that person will uncompress it and it will go back to 1,000 bytes. Reversibly, losslessly. And that is what's going on here. So I'm going to go back to the summary sheet here. This is the essential sheet for everything you'll need to know about lossless compression for the AP CSP exam. I've already gone over the first part, so I'll skip that. Just want to go over the new stuff that we've picked up after doing the Code.org activity. So lossless compression is reversible with no loss of info, but it gives us limited compression, and you'll see that later in our next activity. Lossless compression depends on repeating patterns, and when it comes to lossless compression, different things will compress differently depending on how many repeating patterns they have. If you're looking for practice problems, check out the card in the upper right of the YouTube screen. Alright, so that's pretty much it. Hope that was useful to you, and if it was, please give this video a like and subscribe to my channel. I'll see you next time.